Good morning, dear students. So in the last class, we were discussing so we have completed with methods of preparation of carboxylic acid, right? So we have seen, so 6 methods of preparation of carboxylic acid. Then we have discussed the physical properties. So 3 physical properties we have discussed: physical state, boiling point, and solubility. Then we had discussed the chemical properties, that is reaction involving the cleavage at OH bond. That is how the acidity, okay, how the reactions takes place with metals, alkalis, right? So what are the different type of reaction it can show? So we have discussed that. So today we are going to see the effect of substituents, okay, on the acidity of carboxylic acid. So based upon what type of substituents will be present, okay, how the acidity will alter, okay, how the acidity value or how it will alter, so that we are going to discuss in today's class. So substituents, so mostly they are of two type, okay. One is the electron withdrawing substituent, okay, or called as electron withdrawing group. Another is the electron donating group. Sorry. So electron withdrawing groups and electron donating groups. Okay. So these two types of substituents are present. So we have electron withdrawing groups are present. Okay. What will happen to the acidity of the carboxylic acid? So that we are going to discuss. So acidity of carboxylic acid, okay, it depends upon the electron withdrawing group, okay, which is attached to the carboxylic group. So it depends. Okay, so how this will alter electron withdrawing groups are there. So these are the this what different electron withdrawing groups. Okay, and this is their increasing order of the different electron withdrawing group in their acidic condition. Okay, so electron withdrawing groups, what it will do, it will increase the acidity of carboxylic acid. So whenever electron withdrawing groups are there, so which are the electron withdrawing group? Phenyl group, iodide, bromide, chloride, fluoride, cyanide, nitro group. Okay, then trifluoromethane. Okay, so these what it will do, so these substituents, when they are present on the chain, okay, which consists of a carboxylic group, so what will happen, it will increase the acidity, it increases the acidity. Okay, remember that. So whenever electron withdrawing groups are present, what will happen to the acidity of the carboxylic acid? It will increase. So how it will affect? Okay, so it will thus it increases the acidity and it stabilizes the carboxylate ion. So what is our carboxylate ion? So this is our carboxylate ion, right? So this carboxylate ion, it will be stabilized. Okay, it will be stabilized to the delocalization of this negative ion. Okay, now whenever any electron or whenever any group is attached, okay, now suppose electron withdrawing group is attached. So here you can see electron withdrawing group, what it will do, it is a highly electronegative. Electron withdrawing means what? It will withdraw the electron towards itself, right? Electron withdrawing means what? It will withdraw the electron towards itself. So as it is withdrawing the electron towards itself, what will happen? It will become highly electronegative. So it will show minus I effect. Okay, it will show minus I effect, that is inductive effect. Okay, it will show minus I effect. So inductive effect. So what it is doing, electron withdrawing group is highly electronegative in nature. So what it will do, it will tend to pull the electron towards itself. As a result, the substituents are highly electronegative in nature. Now, to this carboxylic group is present. Now, this carboxylate ion, it has a negative charge. So this negative charge, okay, as I can show you here, so this will be stabilized. Okay, this is a resonance stabilized. So it will be moving. So what will happen? So it will get, what you will get? You will get CO minus double bond O. Okay. Now, so that means what? The negative charge. Okay. So the negative charge will be the resonance. Okay. This what? Stabilized like this. Fine. So this is about so the negative charge is what is happening. It is stabilized by the negative charge of the carboxylate ion is stabilized by delocalization of the negative charge by resonance, or you can undergo a inductive effect. Okay. Suppose now if I give you an example. So I take electron withdrawing group as chlorine. Okay. And I have a chloroacetic acid. Okay. Chloroacetic acid means what? One of the hydrogen is replaced by a chlorine. Right. Acetic acid is what? CH3COH. Right. Now here what I have done, one of the hydrogen is replaced by chlorine. So chlorine is what? It is a highly electronegative atom. So what it will do, it will tend to pull the electron towards itself. Now, suppose I have this chloroacetic acid. So this is what our chloroacetic acid. And one more is what? Acetic acid. Okay, one more is acetic acid. So can you tell me which is highly acidic in nature between these two? So one, what we have done in first molecule, one of the hydrogen is replaced by chlorine atom. In the second, okay, so it is a complete acetic acid. It is an acid. Okay, this is a carboxylic acid. Here, what we have done, one of the hydrogen is replaced by your chlorine atom. So can you tell me which is electronegative in nature? Highly, or you can say which is highly acidic in nature? Yes, relatively, which is highly acidic in nature? First one or the second one? First one, yes, very good. Why? Because there is a presence of a electron withdrawing. So what is electron withdrawing group doing? Electron withdrawing group is withdrawing the electron towards itself. As a result, whatever the negative charge is produced on the carboxylate ion, it will be resonance stabilized. Okay, it will be resonance stabilized. So whenever electron withdrawing groups are present, so please you write down these some of the electron withdrawing group. So whenever such groups are present, okay, if it is attached to a carboxylic group, then what it will do, it will increase the acidic nature. Okay, it will increase the acidity of the carboxylic acid. So what is so greater the electron withdrawing strength, okay, stronger will be the acid. So the first point you need to remember is what? Okay, so greater the number of electron withdrawing group. So greater the number of electron withdrawing strength of halogen, stronger will be the acid. Okay, so this is so fluorine is more stable than chlorine, then bromine, and then your iodine. Suppose I have FCl2 COH. Okay, then I have Cl CH2 COH. Then I have Br CH2 COH and iodine CH2COH. So what will happen? So the fluorine is a highly electro withdrawing group. Okay. So the strength of this will be more. So stronger will be the acid. So this will be more than chlorine, then your bromine group, and then your iodine. So what will happen? So the effect of the electron withdrawing group, okay, it depends upon the order of increasing order. So this is here you can see. So this you have to remember. So this order is very important that you have to remember. So it depends upon this order. Okay. So fluorine is So fluorine is highly electron withdrawing group. Okay, it is a highly electron withdrawing group, then chlorine, then bromine, and then iodine. Okay, so this is important. So remember this order. Order is important. Now, as the number of electron withdrawing group increases, the acidic strength also increases. Now, suppose here you can see what is happening here. What you can see in the molecules, the number of electron withdrawing groups. So here what we have taken fluorine atoms. So here it is fluorine. Here one is there. Here two are there. Okay, and there are no fluorine atoms. So what we are doing? So as the number of electron group increases, acidity of the acid also increases. So which has more? So this one. Okay, so this will come first. Okay, you have to arrange it in the increasing order. Okay, in the increasing order. So which will be least? Your least will be this one. So increasing order means first will be your fourth one. Okay, then will be your fourth is less than your second one. Then will be your third one, and then will be your first one. So this is the arrangement of the molecules in their increasing order. So as the number of electron withdrawing group increases, okay, in the acidic strength also increases. Next, as the distance of electron withdrawing group increases from COOH, its electron withdrawing tendency decreases, and hence acidity also decreases. Okay. So what is the next point? So as the distance of the electron withdrawing group increases, okay. So as the electron distance of the electron withdrawing group increases from the COOH, okay. So what will happen? Its electron withdrawing tendency also decreases, and what will happen to the acidic strength? It decreases. Now here you can see, okay, here is they are at one position. Here you can see. Okay. Yes. Now here you can see. So cyano group is here. Then cyano group is here. So here carboxylic acid is here. Okay. Now here cyano group is here. Carboxylic acid is far. Cyano group is here. This. So what will happen? So the position of the electron withdrawing group. Okay. It also decides the acidity. So it decides the acidity of carboxylic acid. Now, so here, so which will be higher, highest? So we will arrange. So this will be the least. Okay, third one will be the least. Okay, third one will be the least. Then will be your second one. Second one. Then will be your fourth one. Okay, and then will be your first one. So this will be more acidic. Okay, this will be more acidic, and this will be least acidic. So the position of the electron withdrawing group, okay, position least acidic. So the position of the electron withdrawing group in the carbon chain also decides the acidic behavior or acidic strength. Is it clear? Yes. This previous one, so these two examples we have seen, here we will see. Now here, so depending upon the groups present, which will be more acidic in nature. So let us see. Now here nitro. So nitro, okay, nitro is the nitro, you have iodide, fluoride, and this. So this also you order increasing strength. So nitro is the most, phenyl is the least. So phenyl will come first. Okay, phenyl will come first. Then will be your iodo group. Then will be your fluoro group. And then will be your nitro group. So nitro group is the most acidic, and this is the least acidic. So this is the order. Okay. So depending upon the strength also it decides. So this was the first factor which we have discussed. Okay. So depending upon the withdrawing groups. Okay. The strength is decided. So these three concepts we have, three cases we have studied. So next is Direct attachment of the phenyl or vinyl group to the carboxylic acid increases the acidity of carboxylic acid due to resonance effect. Okay. Now, so if the electron, so this is about electron donating. So So here, the fourth factor they have not given. I'll write it here only. So the fourth factor, let me mention it here. So the fourth case is what? So effect of type of hybridization. Okay. Now, if CH2 double bond CH, C double bond O, OH, and CH2, CH double bond C, O minus, OH is there. Okay. So the what will happen? Acidity will increase as the electronegativity of the carbon attached to the COH increases. Okay, so direct attachment of phenyl or the vinyl group to the carboxylic acid will increase the it will increase the acidity. Okay, it will increase the acidity. So what will happen? What will happen due to resonance effect? Due to resonance effect, okay. So direct attachment of this vinyl group will increase the acidity of that particular compound. Okay. So this was about electron withdrawing group. So we have seen four cases. Okay, we have seen four cases now. Next is our effect of electron donating group. Electron donating group. So electron donating group, okay, what it will do? So electron donating group, when it is present to a carboxylic group, okay, or I'll write like this. When it is attached to a carboxylic group, what it will happen? Oh, yes, electron donating means it will give electrons. Okay, donating, it is donating electron. So what will happen? It will decrease the acidic strength. Okay, it will decrease so it will show you plus I effect. It decreases the acidity. It decreases the acidity. How it decreases? By destabilizing, by destabilizing the carboxylate ion. What we are doing? We are destabilizing the carboxylate ion. So what has been done here? Yes. So electron donating group. So it is trying to donate the electron. So because of this, whatever the negative charge is there, okay, which has to be resonance stabilized, it is destabilizing. In the previous, whenever electron withdrawing group was there, what it was doing, it was taking off the electron, right? So the negative charge could be stabilized by the resonance. But here, because of the presence of electron donating group, what is happening? The acidity is decreasing. Why? Because the carboxylate ion is not stabilized. It is destabilized. Okay. So what is happening here? So you can see here. So what is happening here? So whatever the negative charge is there, so this is showing you plus R effect. Okay. So which are the electron donating groups? Yes, which are the electron so you write out this one. So hydrogen, okay, is less than methyl group, is less than ethyl group. Okay, then is your isopropyl group. Then your tertiary butyl group. So this is the different electron withdrawing group. So these are the different electron donating group, not withdrawing group, electron donating group. So these are the methyl groups. Okay, CH3, CH3. So this is CH, CH3, CH3. Okay. So this is the tendency of a electron donating group. So electron donating group, so hydrogen is least and the butyl, tertiary butyl group is the most. Okay. So now suppose Suppose I have here HCOH. I have acetic acid. I have CH3, CH2, COH. Then I have CH3, CH, CH3, COH. Then I have CH3, 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 COH. Can you tell me, yes, how is the order of acidity? Order of acidity, which is the strongest? Which is the strongest? Yes, which is the strongest? Last one. Okay. See here. So if we are arranging the order, okay, in the increasing order of strength, okay. So increasing order. So here you can see that whenever such groups are there, okay. So what it will do if electron withdrawing groups are there. Now suppose I take hydrogen, okay, as the electron withdrawing group, and you have a carboxylic acid here. So this is what? This is a formic acid. This is a formic acid. And another condition I'll take where I have a CH3COOH. Okay. Now, when you have a methyl group, okay, methyl group. So methyl group is a electron withdrawing group. Okay. So this is a strong electron withdrawing group. So what it will do, because of the plus I effect, what will it will do? It will decrease the acidic strength. Okay, it will decrease the acidic strength. So here, I think I've given you the this. So hydrogen will be the more, okay. As your methyl groups increases, what will happen? The acidic strength will decrease, okay. So this is the correct order. So please make this change. So hydrogen will be the least, hydrogen will be the most okay. So this will be most acidic if this group is present. And if this group is present, it will be least acidic. So because of the presence of more alkyl groups, okay, what will happen? The acidic strength will decrease. Now here methyl group is there. So because of this methyl group, what will happen? The negative charge won't be resonance stabilized. Okay. So it will decrease the strength. So whenever I have now formic acid, so formic acid, what will happen? The acidic strength will be more. In formic acid, it will be more, then acetic acid, then your this what? Propanoic acid, and then your butanoic acid. Okay, why? What is the reason? Because as you see here, what is happening to the number of alkyl groups? The number of alkyl groups are increasing. Okay, towards your carboxylic group. Okay, so what will happen? The negative charge on this carboxylate ion cannot be resonance stabilized. So this will be least acidic. Okay, this will be least acidic and this will be most acidic. So if you're, they have told to arrange in the increasing order of acidic strength. So first will be your CH3, CH, CH3COH. So this will be least. Then will be your CH3CH2COH. Okay, less than your CH3COH, and which is less than HCOH. Okay, so this will be the order. So hydrogen will be the most. Okay, hydrogen will be the most, and your this will be the least. Okay, acidic in nature. So this is the increasing order of their acidic strength. Okay, so here also they have given, sit down, you can see. Okay, can you arrange this now? So on the basis of the arrange this, what you can refer the above order and you can tell me this. Apply for this particular example, how it will be. So what will happen to the effect? Yes. So here COH group is here. So 1, 2, 3. Okay. So here what is there? So 1, 2, 3 groups are there. Okay. Now here this group is there. And here your 2 carbons are there. So how will you, oh, okay, 1. So BB has answered it as like this. Others? So you have to arrange it in the increasing order of their acidic strength. Increasing order. So which will be the least? Yes, least will be your first one. Very good. Then 1, 2, 3 carbons, and this is 1 methyl groups. Two methyl groups are there. Okay. Yes. So it will be the third one, correct? Okay. And then will be your second one, no? Then will be a second one because here 1, 2, 3 carbons are there. Here only 2
Yes, ma'am.
carbons are there. Yes. So it will be second one, and then will be your
Fourth.
fourth one. Yes. Yes. Very good. Okay, fine. So this is the arrangement of the acidic strength. So this will be same like this. It will be applied to aromatic this also carboxylic acids also. Now remember that if a question is asked, we have seen that formic acid is there and one acetic acid is there. Okay, why formic acid is stronger? Okay, why this is stronger than your acetic acid? What is the reason? Why in formic acid? So a 2 marks question can be asked like this. So why formic acid is stronger than acetic acid? What is the reason? Formic acid is stronger than acetic acid. What is the reason? In acetic acid, okay, the reason you have to mention is in acetic acid, electron withdrawing group, methyl group exhibits what effect? Plus sign effect. Okay, so in the acetic acid, there is an electron withdrawing group, that is a methyl group is present, and that will exhibit what? Plus I effect. So like this, so 2 marks question. Understood? Is it clear? So the same, let us see for aromatic rings now. So effect of the substituents on the acidity of aromatic carboxylic acid. Okay, so the presence of electron withdrawing group, okay, what it will do? It will so if there is a electron withdrawing group, now if we are discussing about electron withdrawing group, the presence of electron withdrawing group, what it will do? It will increase the acidity. Okay, when we are discussing about aromatic compounds now, okay, same. So electron withdrawing group, if it is present, it will increase, and electron donating group, if it is present, it will decrease the acidic strength of the aromatic compounds. Okay, now suppose I have these compounds. So COH, OCH3, then I have COH. Then I have COH and nitro group. So what will happen here? What will happen to acidic strength? So nitro group is what? Nitro group is the electron withdrawing group. So this will be more. Okay. Then your carboxylic acid, and this is the electron donating group, OCH3. Okay. OCH3 is the electron donating group. So it will be least, and this will be most acidic in nature. Okay, this is this is intermediate because this is the simplest carboxylic acid. So this is the acidic strength. So what will happen? Electron withdrawing group are there, it will increase the acidic strength. If electron donating group is there, it will decrease the acidic strength. So these are the things you have to remember. Okay. Is it clear about the effect of substituents on acidity of compounds? Yes. Is it clear? Yes. Okay. Others? Very important. Okay. So this concept is asked. Okay. Lubna has also understood. Fine. So first chemical reactions we have seen wherein there was the reaction which is involving the OH bond. Okay. Cleavage at OH bond. Next we are going to discuss is the reactions involving cleavage of COH bond. Okay. Reactions involving the cleavage of COH bond. So these are the next reactions. So write down this one also. So second set of chemical reaction were reactions involving cleavage of COH bond. Okay. So first one is formation of anhydrides. First one is formation of anhydrides. So how do we form this anhydrides? So suppose I'll take a general reaction. I have 2 moles of acetic acid. I have 2 moles of acetic acid. What I am going to do? I am going to heat them in concentrated H2SO4. So by taking concentrated H2SO4, we are going to heat this. So what will happen after heating? There will be loss of water molecule. Right? This is a loss of water molecule. So when loss of water molecule is there, what will happen? C double bond O. Yes. C double bond O, R, C double bond O. Okay, so this is shed. So this is what? This is your acetic anhydride. Is it clear? Yes, is it clear? So what we have done here? We have taken 2 moles of carboxylic acid. Okay, we have taken 2 moles of carboxylic acid. Okay, that we are going to heat it. Okay, how we are going to heat it? In concentrated H2SO4. By taking concentrated H2SO4, we are going to heat this. So after heating, what will happen? The water molecule will be lost. And what we are going to get? We are going to get the acetic anhydride. What we are going to get? We are going to get the acetic anhydride. So now tell me the answer for this. Okay. So again, I have taken 2 molecules of acid. I'm going to heat it in concentrated H2SO4. Yes. What I'm going to get? There will be loss of water molecule. Yes. What I'm going to get? CH3, C double bond O, O, CH3, C double bond O. So this is what? What is the name? This is acetic anhydride. Acetic anhydride. And this is what? Acetic acid. So 2 moles of acetic acid. Is it clear? Is it clear? The example is clear?
Yes, ma'am.
Okay. So like this, we can form the anhydrides. Anhydrides, okay? Anhydride means what? There is a loss of water molecule. There is no anhydride. Hydride molecule is not there. Okay. Next is esterification. Very important. Mark this as important. Esterification reactions are very important. We have studied in alcohols also, right? In alcohol chapter also, we have studied about esterification reaction. How is esterification reaction? When a carboxylic acid reacts with the alcohol. When a carboxylic acid reacts with the alcohol in the presence of concentrated H2SO4. In the presence of what? Concentrated H2SO4, or we can take this. So this is what? This is acting as a what? Esters. So what is esterification reactions? Carboxylic acid, they react with what? Alcohol in the presence of concentrated H2SO4 or dry HCl. So these are used as a catalyst to obtain esters. To obtain what? Esters. So what will happen now? So RCOOH plus alcohol. What will happen here in the presence of H plus ions? Yes, what will happen? So this is the H2O molecule. So this is the loss of water molecule. So R C double bond O O R dash. So what I'm going to get? I'm going to get the ester. I'm going to get what? Ester. So R C double bond O O R dash. So this is a ester plus water molecule is lost. Okay. So this is a ester. So let us take an example now. Let us take an example. So tell me now, acetic acid is there. Plus, I'll take a ethyl alcohol. I'll take a ethyl alcohol in the presence of H plus. So this is your acetic acid. This is your ethyl alcohol. Ethyl alcohol or ethanol. Yes. What will be the product obtained, students? What will be the product obtained? Remove a water molecule. Remove a water molecule. What will be the product obtained? Just see. It will be CH3, C double bond O, O, C2H5. Okay. So this is ethyl acetate. What is the product? Ethyl acetate plus H2O. Is it clear? So this is esterification reaction. This is what? Esterification reaction. So esterification reaction, very important, mark important, 2 marks question. Okay. Carboxylic acid, when it reacts with alcohol in the presence of concentrated H2SO4 or dry HCl as a catalyst to form esters. Okay. So RCOOH, that is ethyl alcohol in the presence of H plus will give you ester. We are getting here ethyl acetate as the ester. Okay. Now you have to, is it clear, understood? Is this, both the reactions are understood? First was formation of anhydride. Second one is the esterification reaction. Is it clear?
Yes, ma'am.
Okay. So now you have to tell me, I'll give you one more example. So you have to tell me the answer. So I have benzoic acid. I have benzoic acid. Benzoic acid, I'm going to react it with ethanol. Or you can call it as ethyl alcohol. Ethyl alcohol. So in the presence of H plus ions. Okay, in the presence of H plus ions. What I'm going to get? What I'm going to get? So there will be loss of water molecule. Okay. So byproduct is what? H2O. Yes, tell me now. What will be the product? It will be C6H5 C double bond O O C2H5. What is the name? Ethyl benzoate. Ethyl benzoate. I hope you have got it. So I have shown you 2 examples. Okay, we have solved 2 examples on esterification reaction. Very important reaction, asked for 2 marks. Very important reaction, asked for 2 marks. Is it clear? All the things are clear up to here. Any doubts up to here? Okay. So some more reactions are there. So let us do that in tomorrow's class. Okay, because again, we'll be left with very small part for tomorrow. So tomorrow, one more day, we'll continue with carboxylic acid and we will finish this chapter. Okay. Then from Monday onwards, I'm going to start with a new topic, that is coordination compounds. Okay. So tomorrow, one more day, we are going to discuss about carboxy. You need to ask, yes, anything you want to ask. So in today's class, what all things we have discussed? We have discussed the effect of substituents. Okay, how if there is a presence of electron withdrawing group, what happens? Okay, and this, we have discussed the different cases also based on the electron withdrawing groups. Then we have discussed about the electron donating group. Okay. Then we have discussed about the two name reaction, that is a reaction involving cleavage of COH bond. The two reactions, first one formation of anhydride, second one was esterification reactions. Okay. So these are the next reactions. So let us discuss this in tomorrow's class. That is reaction with PCl5, PCl3. And reaction with ammonia is very important reaction. Okay. Then next is reactions involving COH group. Next is your substitution reaction, very important. Helmholtz-Zelinsky reaction. So decarboxylation reaction, then halogenation reaction is also important. Then we are going to see the ring substitution reaction. And last are the uses of carboxylic acid. Okay, so these all things we'll be discussing in the next class. Any doubts from today's session? Any doubts? Okay, so please practice the name reaction as I'm been telling you. So please practice the name reaction. So I've told you all the important name reactions. Okay, so please practice them regularly. Not only this particular chapter, okay, you have to practice from all the this haloalkanes, haloarenes, alcohol phenols and ethers, right? Then aldehyde, ketones and carboxylic acid. So these three we have completed. So you have to practice from all these three. Fine. Okay. So but now I first to complete this again, after finishing this you can go for the other chapters. Okay, fine. So I'll be ending the session here. Okay, so we'll meet in tomorrow's class. Thank you. Have a good day.